Question 5. Please do that and tell me. Yes, come on. It shouldn't take us too longer than this. Which property is the obvious one to be applicable here? Yes, Radhika, tell us what you did.
So when you add both the limits and you get pi by 2, so you can put it as tan of pi by 2 minus x. Is it that one?
Exactly, yes. So then you will get it as cot of x.
Yes.
Whatever that denominator is, that is not going to change. Mind you, sine will become cos, cos will become sine, but because both have the same powers, that will still be that. Now the key thing is this. First you have to understand that tan of pi by 2 minus theta is cot theta, which is negative of ln tan. So basically we get I equal to minus I. So 2i will be, 2i will be 0, I will be 0. Correct, so option C is right. Ln tan x upon fourth power of sin x plus fourth power of cos x between pi by 6 and pi by 3. Okay, you can see that here. Right, it's symmetric, but it's an odd function also. Well, can we say that it is odd? F of minus x is minus f of x. Well, I can't really say it is odd, but the graph is symmetric about pi by 2. So pi by 2 plus something and pi by 2 minus something, both of them will have same value in mod, but different values because of the sign. Okay, so let's integrate this now. Okay, let's integrate this now. Okay, so that's 0. In fact, if you take anything of this sort, pi by 4 plus a, pi by 4 minus a, okay, it would still be 0. Okay, it would still be 0, and the range of a, I think that would also be a good question. They can ask you to evaluate a range of a for which the integral is defined. Okay, and what answers will you give you for that? Yes, come on. What answers will you give you for the range of a for which this integral will be defined, or the function will be defined? Can you tell me that? Is the question clear?
So won't AB cancel every time that we will be using these?
Yes, but again you don't pay enough attention to the domain of the function. That's basically what I was trying to tell you the other day. Correct, this integral is not defined because the function has a discontinuity in between. Do you realize it now? Just like that, here look, we also need to take into consideration the domain of ln tan x, because sin raised to 4x plus cos raised to 4x, we know what its domain is. Its domain is a set of all real numbers, and additionally both of them are never negative, both of them are never 0. So there is no question of denominator being 0, but there is definitely a possibility of numerator being undefined. And when is that going to happen? That is going to happen when tan x is negative. Understood? Or 0? Is it clear? Yes, no? So a has to be less than pi by 4. Correct? A has to be less than pi by 4. Otherwise, what will happen? Okay, or let me rather, okay, for safer side, let me write it like this. Tan of x should be greater than 0, only then it will be defined. If you want tan x to be positive, okay, if you want tan x to be positive, you want the angle to be greater than 0. So that automatically gives you a to be less than pi by 4. Have you understood this? Or no?
So, but what about
And
the
we
upper
speak
limit?
Sorry? Upper
Upper
limit
limit.
is still okay. Pi by 4 plus pi by 4 is pi by 2. That's still fine. Beyond that, we can't go. That's what I'm saying. A less than pi by 4. The moment a becomes greater than pi by 4, lower limit becomes negative and you can't really substitute it as x. Because tan of negative theta is negative tan theta. Clear?
That means we have to make the
We
tan
have
of
to we have to find the domain of the function, basically. And the interval of integration has to be a subset of that domain. If it is not, then make appropriate changes, split the integral and evaluate it independently. Is it clear?
yes.
So that is a possible MCQ. Range of values of a for which integral is defined or for which I is equal to 0. ठीक है? Alright.